Hello students, you are welcome to your favorite YouTube channel, Physics for Everybody. So today we'll be solving questions on the October-November year 2022, paper 1, okay? Paper 12 actually, that's been paper 1 type 2, your core examination, physics. So we go straight to what we have to do today. We'll be solving all 40 questions and we try to solve all of that within 45 minutes. Let's go. Question 1. Which measuring instrument can be used to find the volume of a small stone? If you want to find volume, the best instrument to use for a small stone is a measuring cylinder, okay, partly filled with water. Option A, okay, so you must have done this when you are learning density. Question 2. The diagrams show the speed time graphs for 4 different bodies moving for 6 seconds. Which body traveled the least distance? How do you find the body that traveled the least distance? You know, the distance is the area under the graph. The area here, this area I'm shading represents the distance here. And the shape here is a triangle. So the area of this shape is half base times height. That's how you find the area of this triangle, okay? For this triangle, the base is from here to here, that is 6, and the height is from top to bottom, which is 8, okay? So you have it as half times, your base is 6, 6 times, the height is 8. Half times 6 times 8 will give you 24 meters. So we do the same thing for the other shape. We find the area that is bounded by the slope, okay, the area bounded by the gradient, which is the area that I've shaded here. You can see there are two triangles here. The area of the first triangle, you do half times base times height. This is the base of the first triangle, that's the bigger one, okay, and this is the height. Then you do the same thing for the smaller triangle. This is the base of the smaller triangle, and here we have its height. What's the area of the bigger triangle? Half times base times height. What's the base of the smaller triangle? 2. So we have, sorry, it's 4. Half times, the base is 4, the height is 8. Half times 4 times 8, that gives you 16 meters. Now let's do it for the smaller triangle, okay? The base of a smaller triangle is from 4 to 6 is equal to 2, okay? Yeah, the base is 2, and the height is the height, this is the height from bottom to top, okay, and you say that the height is 4, okay, this level rhymes with 4, so the height is 4. So you have the smaller one will be half times base, that will be half times, the base is 2, half times 2 times the height is 4. Half times 2 times 4 will give us 4. Now you add together because there are two triangles here, the bigger one and then the smaller one. So add the area of the bigger one and the smaller one. 16 plus 4, that will give us 20. 16 plus 4, that will give us 20 meters. So in the first case, we got 24 meters. In the second one, B, we got 20 meters. Do the same thing for C. The area formed here is the total shape, okay? That's the area formed between the slope and the horizontal axis, the time axis. So you just multiply. The shape here is a rectangle. Area of a rectangle is length times breadth. So multiply 6 times 8. 6 times 8 gives you 48. Yeah. And the last one, you get the area of this shape, okay? Get the area of this shape, then you get the area of this other shape. So there are two rectangles here. The area of the bigger rectangle is length times breadth. The length is 4, the breadth is 8. 4 times 8 will give you 32. So you add 32 plus the smaller one, the length is 2, the breadth is 4. 2 times 4 is 8. 32 plus 8 gives us 40 meters. So which one has the lowest distance? The lowest value is this 20, okay? Yeah, when you are comparing all the length, 48 meters, and the last one 40 meters, you see that the lowest one is this 20 meters, which is option B. So the correct answer to number 2 is option B, which is 20 meters. Let's go to question 3. Which row shows the mass and weight of an object near the Earth's surface? Um, Weight is equal to mass times gravity. Do not forget that gravity near the Earth's surface is 10. So let's deal with the first one. If mass is 0.2, weight can never be 0.2. Mass and weight can never be equal. So this is wrong. If mass is 2, what will be the weight? Let's multiply weight by 2. Let's multiply mass by 10 to see if you get the weight. So when the mass is 2, let's go. Weight is mass times gravity. Remember that gravity is 10, okay? So 2 times 10 gives us 20. That means the weight here is supposed to be 20, but it's written as 0.2. Okay, that means this is not correct. Let's go to the third one. When mass is 2, weight is 20. Yeah, when mass, remember I said here, when the mass is 2, weight will be mass times gravity. Gravity is 10. 2 times 10 gives us 20 Newton. So option C is the correct one, okay? Yeah, because when mass is 2, then weight will be 20. That's why we'll be shading option C because it's the only correct option. If you try it with option D, multiply 20 by 10, you should get 200, and this is 10, not 200. So that leaves us with option C. Question 4. The diagram shows 4 pieces of laboratory apparatus. Which piece of apparatus are used to find the density of a liquid? So you have to find the apparatus that is used to find the density of a liquid. Now, which of these apparatus would you use to find the density of a liquid? Remember that the formula for density is mass divided by volume. For which apparatus would you use to find the mass, and which apparatus would you find the density? Okay, good. Do not forget that you are dealing with a liquid. Okay, sorry. Which apparatus would you use to find the mass, and which apparatus would you use to find the volume? Rather, please. So how do you find the mass of a liquid? You place it on a balance, you place it on the scale. After that, then you pour it in the measuring cylinder to find the volume. So option B is the correct answer. We have the balance and the measuring cylinder. Question 5. What is the SI unit of moment of a force? Moment of a force is the product of the force times distance. That's the formula for moment, okay? And force is measured in Newton and distance is measured in meter. And that's why the SI unit of moment is Newton meters. Option D is the correct answer. Question 8. On which ball is a non-zero resultant force acting? Option A ball moving at constant speed on a smooth surface. Correct. When an object is moving at a constant speed, when speed is constant, what does that mean? When speed is constant, it means acceleration is equal to 0. Do not forget that force is equal to mass times acceleration. When acceleration is equal to 0, then what's the value of the resultant force acting on the body? You multiply mass times acceleration. Since acceleration is 0, mass times 0 is 0. So the resultant force is 0 when what? When acceleration is 0. And when acceleration is 0, then we say an object is moving at constant speed. Okay, that makes option A the correct answer. I've not even looked at B and C. Let's look at B. A ball at rest on a smooth bench. A ball at rest on a bench. On which ball is non-zero resultant force? Oh, sorry. Non-zero, that's the question. In the case of A, the resultant is 0. Okay, so that's not the correct answer. Okay, when the resultant force is 0, then we say the body travels at constant speed. But when they say non-zero, that means you don't want the resultant force to be 0. Okay, and in the case of A, the resultant force is 0. So this is not the correct answer. A ball at rest. Hold on, please. Alright, so option B shows a ball at rest on a bench. When a ball is at rest, then the resultant force must be equal to 0. So this is not the answer because we want a non-zero resultant force. Okay. Option C, a free-falling ball which has just been released. Yes, this is when the resultant force is non-zero. Why? Because the resultant force is equal to the weight of the object. Yeah, the weight will always bring it downwards, and weight is mass times acceleration due to gravity. And that's why we have gravity acting this way, okay? The weight acts in this direction, downwards. That's why the object would move in this direction, okay? Due to gravity. Option D, a ball floating on water. When a ball is floating, then the forces on it are balanced. So the net resultant force here is 0. Hence, this is not the answer. Question 7. Question 7. Which statement must be correct for an object to be in equilibrium? Number 1, the object is moving in a straight line. Option number 2, there is no resultant force on the object. Number 3, there is no resultant moment on the object. These are the two conditions, okay, the last two. Number 1 is not a necessary condition, okay. The object can be at rest, okay. It must not necessarily move in a straight line. It must be at rest, okay, and it can also move on a straight line. But it is not compulsory for an object to move in a straight line for it to be in equilibrium. It can also be at rest and be in equilibrium. So 2 and 3 are the correct options. That makes C the correct answer to this question. Question 8. An object falls towards the Earth's surface. What happens to the gravitational potential energy and to the kinetic energy of the object? In this case, the gravitational potential energy decreases, then kinetic energy decreases. No, kinetic energy is not decreasing. Why? Because if an object is falling towards the surface of the Earth and it is falling downwards, acceleration due to gravity causes what? Because of acceleration due to gravity, the velocity of the object keeps increasing, okay? So the velocity keeps increasing. Hence, kinetic energy, which is equal to half mv squared. If velocity keeps increasing, then it means kinetic energy continues to increase, okay? Yeah, because the object keeps traveling faster, the speed continues to increase. I mean, its speed downwards continues to increase. That means kinetic energy continues to increase. So this is not correct. B is the correct answer, okay? Why? Gravitational potential energy is decreasing. Why? Because it is falling. When something is falling, that means the height of that object above the ground level continues to decrease. Yeah. You know, the fact that it is falling, later it will be in this position, okay? That means the height becomes from here to here now. Initially, the height was from here to here, but now the height has reduced to from here to here. So since height is decreasing, then it means gravitational potential energy continues to decrease. So B is the correct answer, okay? Potential energy keeps decreasing while kinetic energy keeps increasing. Question 9. Which source of energy is not currently used to generate electricity? Which one? Is it nuclear fusion? Some countries use nuclear energy to generate electricity, but the form of energy they use is the one from nuclear fission and not nuclear fusion. Okay, nuclear fusion, that is the one happening in the sun, and we've not developed our technology to the point of using nuclear fusion to generate electricity. So A is the correct answer to question 9. Question 10. A mass is lifted from rest on the ground to Y. You know very well that all these other ones are used to generate electricity. Nuclear energy, solar energy, tidal energy from waves, okay? From waves no, sorry, waves energy from waves in water. Tidal energy is energy that is due to tide. That is when the moon is directly above the surface of the earth, it causes water level to rise, okay? So sometimes they can build a dam and create a barrier. So when the moon is no longer above the sun, the water level falls to the normal level. But once it falls to the normal level, what happens to this dam here has already kept this water here hidden. It has stored it. So by the time the moon leaves and water level eventually goes down, water has been stored here, and that water can be used to generate electricity. This water that has been stored here can be used to generate electricity. That's what we mean when we say tidal energy. You can Google it and watch videos on tidal energy to understand what it means. So all these other ones can be used to generate electricity except nuclear fusion. Number 10. A mass is lifted from rest on the ground to Y. There is no air resistance. P is the increase in gravitational energy of the mass. Q is the kinetic energy of the mass at Y. Which expression is equal to the mechanical work done on the mass? Well, the mechanical work done on the mass, let us look at the options available to us. Option A, P plus Q. Option B, P minus Q. Option C, Q minus P. Option D, P times Q. Now look at this. P is increase in gravitational potential energy. You know, when you are lifting a mass, you are giving it gravitational potential energy, right? Good. So P is gravitational potential energy given to the mass. Q is kinetic energy of the mass. Also, the mass that you are lifting upward, you are lifting it upward at a certain speed. Okay, and as long as you are moving it upward at a certain speed, that means you are giving it some kinetic energy. So the total mechanical work done on the mass now, the work you are doing on that mass will be the kinetic energy you are giving to the mass plus the potential energy you are adding to the mass. Okay, remember that Q represents kinetic energy. Okay, so you just do Q plus P. That's the expression that gives you the total mechanical work done on the mass. So we go straight to question 11. Question 11, a pressure gauge is lowered into the sea. Measurements of the pressure and depth are taken as the pressure gauge is lowered. Which statement describes how and why pressure changes as the gauge is lowered? A, the density of seawater decreases as pressure increases. B, the depth of the gauge below the surface of the sea increases, so the pressure increases. B is the correct answer. Why? Because pressure in liquids is equal to density times gravity times height. Okay, height or depth. So as the height or the depth is changing, then automatically you expect the pressure to change. Good. So question 12. The pressure of a fixed mass of gas in a cylinder is measured. The pressure of a fixed mass of gas in a cylinder is measured. The volume of the gas in the cylinder is slowly decreased. The temperature of the gas does not change. Which graph shows how the pressure of the gas changes during this process? So a graph of pressure against time. A graph of pressure against time, in this case, let me see. Okay, the pressure will be increasing with time. Okay. The volume of the gas in the cylinder is slowly decreased. When you are decreasing volume, what happens? Pressure is proportional to 1 over volume. Okay, that means pressure is inversely proportional to volume. That simply means when volume is increasing, pressure will be decreasing, and when volume is decreasing, pressure will increase. Okay, now when volume is slowly decreased, that means pressure is meant to be increasing with time. Okay, so ideally many people would expect option B to be correct, but option B is not correct because the pressure of a gas can never be zero. So the graph should never start from the origin. That's why we are picking option C. Okay, because pressure can never be zero. The pressure of gas can never be zero. As long as we have gas molecules, then the pressure can never be zero. It's only in a vacuum that you have pressure being as low as zero. Question 13. Which statements about the motion of molecules describe the process of evaporation? A. Molecules break free from their fixed position. That's melting. Option B, freely moving molecules collide and join together. That's condensation. Option C, molecules escape from the surface of a liquid. Correct. That is what evaporation is. Okay. Option D, freely moving molecules gain energy and move further apart. That is Well, that should be expansion of liquid and gases. Question number 14. The diagram shows a thermometer calibrated in degrees Celsius. What are the values of the lower fixed point and the upper fixed point on the Celsius scale? Lower fixed point is 0 degrees Celsius and upper fixed point is 100 degrees Celsius. That makes option C the correct answer. Question 15. What happens to a solid when its temperature increases? What happens to a solid when its temperature increases? When you increase the temperature of a solid, what happens? It contracts, no. Its density increases, no. Its internal energy increases. That is correct, okay? Because temperature is what? Is a measure of the total internal energy of a body. So when you are increasing temperature, then you are increasing the internal energy, okay? If the question was talking about melting, then you can say the molecules move freely, okay? Because during melting, molecules begin to move freely. But when you talk about internal energy, then we are talking about temperature. Question 16. Which piece of equipment is designed to produce a type of electromagnetic wave? A. Electric fire, B. Electric generator, C. Electric motor, D. Electromagnet. Electromagnet would produce magnetism. Electric motor will produce electric current. Electric motor would produce a force when electric current is fed into it. Electric generator will produce electric current. Electric fire would produce electromagnetic wave. And what type of electromagnetic wave is that? Usually it is infrared rays. Yeah, that is what deals with heat. When heat is involved, then you know infrared rays are involved. Question 17. Particles can move, transferring thermal energy as shown. In which state of matter does this movement occur? Then this should be in liquid and the gaseous state. Why? Because molecules of solid are fixed in position and they can only vibrate about their main position. But in the case of liquid and gas molecules, liquid molecules can move freely and gas molecules can also move freely. So option A is the correct answer, gas and liquid only. Question 18. The diagram shows plane water waves in a ripple tank passing through a gap between two barriers and spreading out. Which name is given to this effect? This is diffraction of waves. Option A, diffraction of waves. Okay, good. Question 19. What are the correct labels for the ray diagram? Option X should be the no. Okay, so let's see. Let's start with A. W, what is W called here? Position of objects. Yes, W is the object. X, X is not the image. No, this is not correct. Let's go to option B. W is the object. Z is the image. That's correct. Then principal focus labeled as Y. That's correct. Option B is the correct answer. Yeah. Well, yes, this is the principal focus. That's why this is the image. This is the image. This is the principal focus. This is the object. This is the optical center. X is the optical center. Optical center is not mentioned here. So let's just focus on what is mentioned in the question. B is the correct option. Question 20. The diagram shows an object in front of a plane mirror. At which label position is the image of the object formed? You know, this is the object, right? So since this is the object, then the image will be just at the same position. If you produce a normal line, then you know the image rather will be at this position B. Okay, that makes B the correct answer. That makes B the correct answer to this question. So question 21. The angle between an incident ray and the surface of a plane reflecting ray is 70 degrees. What is the angle of incidence? You know, we have a plane mirror and the question says, so let this be our plane mirror. The question says the angle between an incident ray, this is the incident ray, and the surface of a plane mirror. So this angle here is 70 degrees. 70 degrees. What is the angle of incidence? You know, we have to produce a normal at the boundary the between the incidence ray and the reflecting surface. Let me use a different color for this purpose. Let me use the black color, the black ink. So I want to produce a normal. That's a perfectly perpendicular line to the reflecting surface. Now, since this is the incident ray will be reflected along the same path, right? Good. Now, since this normal is perpendicular to the reflecting surface, let me erase this, I don't need this. Since the normal is perpendicular to the reflecting surface, that means there's a 90 degrees here. So since it's perpendicular, also the angle formed on the left hand side must be 90 degrees. Okay, so how do I get the angle here? The question says, what is the angle of incidence? The angle here is the angle of incidence, the angle between the normal and the incidence ray. This is the angle of incidence. Do not forget that this is the angle of incidence I. Do not forget that since the angle here, this perpendicular line, the normal, since the angle here is 90 degrees, that means adding this 70 degrees plus this angle I should be equal to 90 degrees, which is the total angle. So that means that means 70 plus I should give us 90 degrees. So how do you get I? Your I must be equal to 90 minus 70. 90 minus 70 gives us 20 degrees, and that is the angle of incidence. A is the correct answer to question 21. Let's move to the next one, question 22. We go straight to question 22. Visible light has a frequency of approximately 5.0 times 10 raised to the power 14 Hz. M and N are two other types of electromagnetic radiation. The frequency of M is 5.0 times 10 to the power 6 Hz. The frequency of N is 5.0 times 10 to the power 15 Hz. What type of radiations are M and N? Now we try to list out all the components of the electromagnetic spectrum. What do we have? We have radio waves, we have microwaves, we have infrared rays, we have visible light, we have visible light, we have ultraviolet, we have X-rays, and we have gamma rays. These are all the components of the electromagnetic spectrum. Now, light is 5 times 10 to the power minus 15. Yeah, so we were told that visible light is 5.0 times 10 to the power 14 Hertz. Also, okay, let me use a different color to write that out so everything does not mix up together. Now, we were told that visible light is 5.0 times 10 to the power 14 Hertz. Also, M has a frequency of 5 times 10 to the power 6. That means it must be a very low value, 5 times 10 to the power 6 Hertz. That is M. And as for N, it's 5 times 10 to the power 15. That means it must be something higher than this value of visible light. So we can put 5 times 10 to the power 15 here. Now the question says, which type of radiation are M and N? We have radio waves. You know, this is N, right? Good. We have radio waves. Well, it's possible for M to be radio waves. That's good. Then N, infrared. N cannot be infrared because the frequency of N is higher than the frequency of visible light, and we have this value for visible light. Option B says radio waves and infrared rays. Radio waves for M, that's good. What about N? Infrared? No, ultraviolet rather. Ultraviolet, yes, that is very possible. That's very possible. So option B is very possible. Let's look at C. Ultraviolet from M. M cannot be ultraviolet, okay? Because ultraviolet must have a frequency higher than the frequency of visible light. Then D, we have X-ray, and can M be X-ray? X-ray is down here, and the frequency of M is lower than the frequency of visible light. So M can only be one of these values because these are the rays that have frequency lower than the frequency of visible light. And N can only be one of these because these are the only rays whose frequency is higher than the frequency of visible light. That's why we're given the frequency of visible light in the question. So B is the only condition. Those are the only options that satisfy those conditions. So B is the correct answer to question 22. Let's go straight to question 23. So students are describing different types of electromagnetic radiation. Student 1, the radiation is used in communication, okay? Student 2, the radiation is used in remote controllers. Which row shows the possible type of radiation that each student is describing? Which radiation do we use in communication? We use microwave in communication. And remote controllers use infrared rays. That means A is the correct answer to question 23. Let's go straight to 24. A 100 meters race is started by firing a gun. The gun makes a bang and a puff of smoke at the same time. When does the finishing judge see the smoke, and when does he hear the bang? Number A, the smoke immediately. He sees the smoke almost immediately. Well, that's correct. He sees the smoke almost immediately because seeing has to do with light, and light has a speed of 300 million meters per second. Then hearing has to do with sound. Sound is slower. The speed of sound is around 300 meters per second. So he hears the sound almost immediately. That's not possible. He hears the sound after 0.3 seconds. Yes, he hears the sound after 0.3 seconds. Why? Because speed is distance divided by time, and the time will be, if you make time the subject of formula, time is equal to distance divided by speed. What's the distance? This distance is 100 meters as stated in the question. If you divide 100 by the speed of sound, the speed of sound is about 300 meters per second. So if you divide 100 by 300, you'll be getting something like 0.33. You get it? Yeah. And if you want to use the higher value for speed of sound is around 300 to 340 meters per second. Okay. Yeah. So you'll be getting the time to be around this value, 0.33 seconds. Okay. That means option B is the correct answer to the question. I hope this is clear. Good. So let's go straight to the next question. Question 25. An electric hair dryer is rated 230 volts 2 amperes. Which circuit could be used to check that these ratings are correct? So this is voltage. You measure voltage with a voltmeter. Ampere, that's current, to measure with ammeter. You can't connect voltmeter in series in a circuit, so this is wrong. This ammeter cannot be connected in parallel. This is wrong. Ammeter can never be connected in parallel. This is wrong. Ammeter in series, voltmeter in parallel. This is correct. That means option D is the correct answer to question 25. Question 26. The diagram, question 26. In question 26, we have that the diagram shows a circuit used to control the potential difference across a lamp. The variable resistor is adjusted until the potential difference across the lamp is. The diagram shows a circuit used to control the potential difference across a lamp. The variable resistor is adjusted until the potential difference across the lamp is 6 volts. The current in the lamp is 5 amperes, is 0.5 amperes. What is the resistance of the lamp? According to Ohm's law, V equals to I R. Now we are looking for the resistance. That means R equals to V over I. The voltage in this circuit is 6 volts and the current in this is 0.5 amperes. So if you divide 6 by 0.5, you get 12. Okay, so the resistance is 12 ohms. That makes option D the correct answer. Question 27. What are the units of electromotive force? Electromotive force is EMF, okay, and is measured in volts, D. Question 28. A plastic rod is rubbed with a dry woolen cloth. The rod becomes positively charged. Which statement is correct? Okay, so if you rub a plastic rod with a cloth, okay, dry woolen cloth, the rod becomes positive. So if the rod is becoming positively charged, what does that mean for the woolen cloth? That means the woolen cloth becomes negatively charged. Okay, that's what it means. Okay, so if something is becoming positively charged, that means electrons have left the rod and have migrated to the cloth. Electrons are negatively charged, so when the electrons move to the cloth, that makes the cloth negatively charged. Okay, good. So it shows that electron moves from cloth to the rod. That's not correct. Electrons move from rod to the cloth. Option B is correct. Electrons move from the rod to the cloth. That's why the rod becomes positively charged, because it has lost some electrons. Question 29. A circuit containing a cell, a resistor, and a lamp is set up as shown. A student connects a voltmeter to the circuit in one of the positions shown. In which position does the voltmeter measure the potential difference PV across the lamp? You want to measure potential difference across the lamp, then you have to connect the voltmeter across that lamp. So is voltmeter connected across the lamp? Okay, this is good, but this is not good, because these voltmeters are not measuring anything. Okay, so also this is measuring the voltage across the cell, not across the lamp. So it's only C. This is the correct the correct connection that measures voltmeter across the lamp. That is option C. Question 20. Question 30. The diagram shows a potential divider circuit. The temperature of the thermistor increases. What happens to the resistance of the thermistor, and what happens to the reading on the voltmeter? When the temperature is increasing, then the resistance of the thermistor will drop. Okay, so resistance of the thermistor will reduce. Okay, once the resistance of the thermistor reduces, then it means the voltage across the thermistor will reduce. Yeah. What happens to the resistance of the thermistor, and what happens to the reading on the voltmeter? So once resistance of the thermistor reduces, then the voltage that the voltmeter will read will reduce. Why? Because voltage that it will read is equal to IR. So if R is dropping, if R is reducing, automatically it means the voltage will also be reducing. Okay, so both of them will decrease. That makes option A the correct answer to the question. Question 31. A student sets up 4 circuits using identical batteries and 3 identical lamps. In which circuit will all the lamps be the brightest? All the lamps will be brightest when they are connected in parallel, which is option D. Why? Because the current that will be flowing from the cell will split into these cells. But take note that each of these cells will see a voltage that is equal to the voltage of the battery. But in other cases, the voltage will be divided between this lamp and these 2 lamps. In the first case, the voltage will be divided into 3. Okay, yeah, so since V equals to IR, once voltage is reducing, automatically it means the current that is flowing through the lamp will reduce, hence it won't be bright. In this case, the voltage, yeah, this will be bright, but this too will not be very bright. Okay, but now you are interested in all the lamps being brightest, and this is the case, option D. That's when all the lamps will appear to be very bright, because they are all connected in parallel. We go straight to question 32. In which diagram shows the circle symbol of a fuse? This is the circle symbol of a fuse. A fuse is just a very thin wire inside an insulating casing. Question 33. If the insulation within a mains cable becomes damaged, 2 of the wires in it may touch and cause a short circuit. Which row is correct? The danger when this happens is that a large current will overheat the wiring and lead to a fire. Then a safety device which avoids this danger is a fuse. Option A is correct. Okay. So during short circuits, large currents will flow, which can damage the circuit. And fuses are used to do what? To put a limit. Fuses place a limit on the current that can flow in the circuit. That means option A is the correct answer. Question 34. Four small compasses are placed around a solenoid. A current is now switched on in the solenoid. Which diagram shows possible new directions of the compass needles? Okay, now when you switch this on and current flows, that means a magnetic field will be created within this solenoid, and magnetic lines of force they move. This is the path the magnetic lines of force will follow. The magnetic lines of force will create this pattern. Let's see. So this one can never point this way. Sorry, this one can never point this way. It will point in a direction that is parallel to the direction of the field. Okay, good. So option A is not correct. Let's go to option B. B is not correct. They are both pointing in a different direction. Option C. C is correct. Okay, C looks correct. Let's look at option D. This one pointing to the left, this one pointing to the right. That is not correct. They must point in the same direction. So option D is the only correct answer. Okay. So in this case, then we can see that the considering the direction of the current flowing, okay, the arrows now show the direction of the current. So magnetic lines of force will go this way and return. Okay, they also go this way and return. Okay, and here we have the lines of force going this way. Okay, so this arrow shows the direction of the lines of force. No, yeah, this arrow shows the direction of the line of force. So we have the same thing here. Okay, the arrow shows the direction of the magnetic lines of force. I hope this is clear. I hope this is understood. Yeah, this is understood. So D is the correct answer to this question. We go to question 35. Transformers are used in the transmission of electrical power to houses. Which type of transformer is used at the power station prior to connection to the power lines? And which type is used prior to delivery to houses? Option A, in power station, do we have step down transformer? No, it's step up transformer we have, okay? And the one close to your house is a step down transformer, which makes option C the correct answer. Why? Because at the power station, we want to step up the voltage. Okay, when we step up the voltage, then we can transmit the power through the power cables. Okay, but the one at your house, you want to step down the voltage so that the appropriate voltage can go into your house. Okay, some countries use 240 voltage, some countries use 220 volts. Okay, but at the power station we want to transmit at voltage as high as 33,000 volts. Okay, some countries transfer at 132,000 volts, some countries transmit at 330,000 volts. Okay, in order to reduce losses. So at the transmission station we have the step up transformer, and at your end, which is your distribution station, we have the step down transformer so that you can receive the voltage that is appropriate for your gadgets. Okay, yeah. So we go straight to question 36. Question 36. The diagrams show the coils of two simple direct current DC motors. Coil P has 3 turns of wire and coil Q has 2 turns. Coil P has the same dimension as coil Q. The coils are in identical magnetic field. What produces the greatest turning effect? The greatest turning effect, that is talking about the force, and the force produced by a coil is BIL, okay, or you say BQV, okay, good. So in this case, There's no mention of the speed at which the coil is turning or the electric charge. So we focus on this formula. Okay, so in this case, B represents the magnetic field. Since they are both in the same magnetic field, I is the current. So the one that has greatest current and the greatest length, that's the one that will have the greatest force. Which one has the highest length? Is the one with the higher number of coils. This one has more number of turns. That means the length, total length of the conductor is higher. Then we want the current to be high as well, which makes option B the correct answer. Okay, because coil P has greatest number of turns and it has higher current flowing in it. So we go straight to question 37. Question 37. A nuclide of cobalt contains 27 protons and 32 neutrons. Which symbol represents this nuclide? CO. Okay, so how do you get the mass number? The mass number is equal to number of protons plus number of neutrons. So now let's add 27 plus 32, that will give us, 27 plus 32, that will give us 59, right? Good. This makes question option D the correct answer, okay? The one above is the mass number and the one below is the atomic number. You go straight to question 38. Everyone is exposed to background radiation. What are sources of background radiation? A, food and drinks only. B, rocks only. C, cosmic rays only. D, food, drink, rocks, cosmic rays. Yeah, all of these are sources of background radiation. Question 39. The diagram shows a piece of apparatus used to determine the nature of the emissions from a radioactive source. The absorbers can be raised out of or lowered into the path of the radiation from the source of the radiation from the source to the detector. The apparatus is evacuated. The table gives a set of results for a particular radioactive source. Absorber in use, then count rate. When no absorber is used, we have count rate is 350. When tin paper is used as the absorber, we have count rate as 350. When 1.0 millimeter aluminum, we have count rate of 180. When we have 1 centimeter lead, count rate is 23. Which type of radiations are being emitted by the radioactive source? A, alpha particles. Beta particles. C, beta particles and gamma rays. D, beta particles only. Okay, you see, in this case, if you look at these, no, alpha, beta particles and gamma rays. Now, if you look at all of these, you know that the perfect material that actually the perfect absorber rather in this case is the 1 centimeter lead. Yeah, 1 centimeter lead, that's the best absorber in this case because this is the only case where the count rate is lowest. And when we talk about lead is the only material that absorbs alpha particles, beta particles and gamma rays. Now when you are not using any absorber, we have 350. When you are using tin paper, you have 350. So it's as if this tin paper is not effective. Tin paper can only block alpha particles, but you can see there's no difference. That means alpha particle is not being obstructed. That means there's no alpha particle in this case. Now aluminum can only block alpha particles and beta particles. You can see there's a reduction when you use aluminum. That means beta particles are present. When you use lead, the reduction is very least. The reduction is least. Yeah, the count rate is least rather. That shows that there is gamma rays and there is also beta particles. That means option C. Yeah, beta particles and gamma rays. That means option C the correct answer. Now question 40. The half-life of a sample of radioactive material is 400 years. How long will it take until 1/4 of the sample remains undecayed? Okay, so if half-life is 400 years, yeah, so how long will it take for 1/4 to remain undecayed? So after 400 years, half would have decayed. That means you have left with half. After another 400 years, so half times half will decay again. Okay, that means quarter will decay. Okay, sorry. Yes, 1/4 will decay. Okay, so in this case, the total that has decayed, after 400 plus 400 years, the total that has decayed will be half, which is for the first 400, plus quarter, which is for the second 400. This will give you 3/4. So 3/4 will have decayed. What will be left will be 1/4. Okay. So the correct answer will be 400 years plus 400 years, which is 800 years, which is option C. This brings us to the end of your 2022 October November IGCSE 0625 paper 12. That's paper 1 type 2 multiple choice question. So next video we'll be solving the third variant of the paper 1, and then we'll move straight to our paper 2. Thank you for watching the video. Ensure you subscribe and share this video with your friends. Do have a nice day. Goodbye.